Hey there, everyone. This is my Lab 2 charge tape revisited, and my name is Jeremy McWhorter. So first off, introducing this lab, the purpose of it is to section off the tape into smaller segments and then use them as point charges to find a more accurate charge for each tape, instead of in the last lab, we had each piece of tape being a point charge instead of it being segmented. And then for our lab, we'll be using topics such as Newton's third law, which is the law of reactionary forces, superposition of charge, as well as distributed charges. And then just a quick preview of the end result. The charge on each tape ends up being 2.746 times 10 to the negative 8 coulombs in this version of the lab. So for this lab, we used these equations: Newton's second law, F equals ma, the equation for electric field, which is kq over the magnitude of r squared times r hat, which is the unit vector, and then the electric force formula, which is F is equal to QE, and then outlining our system and surroundings. In this lab, the system was the piece of tape B, and then the surroundings were everything else, which includes the Earth. So important data that we gathered from last lab that we end up using in this version is that G is equal to 9.81 times meter per second squared, and then K, the value of the charge, is 1.6 e to the times 10 to the negative 19 coulombs. And then following are the mass, tape length, and then the separation distance for the piece of tape. And finally, the result we end up getting is the charge 6.407 times 10 to the negative 9th coulomb. So here is some of the code that I used in the lab explained. So up here at the very top on the left, we have all the different definitions for the constants, such as gravity and the length and the electron charge. Then falling down, we have more things defined, such as the charge. And then next, we are actually defining the parts of our equation, the variables in our equation that we have used, such as the magnitude of r and r hat. And then up here, we are scaling everything. And finally, in this last bit of code right here, we actually write the answer and have the arrows printed out. So that's just a brief overview of the GlowScript code. So these are the results of the pictures in GlowScript. So for this lab, these two equations were used on the left, and these are both derived in class. And then on the right, we have what you would actually see in GlowScript, which is the white arrow and the yellow arrow, representing the electric field produced by the piece of tape. And that's just the text box that was outputted. So some possible sources of error that we could have made during this lab, and some possible assumptions that we made. So first of all, the assumptions that we made were that the tape charges are the same and that the tape charges are equal. Another one was that the total charge is the sum of these segments. So those are the two assumptions. And then some possible sources of error that we didn't really think about were the air resistance that each piece of tape has, as well as some of like the currents in the room, maybe when you took measurements of the data. And then maybe even the electric field induced by your hand or other objects in the room that could have affected the piece of tape. So why? We have a question. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? So they differ. These two ones are differed drastically in the terms of accuracy. The line charge model is significantly more accurate because it takes smaller steps along the length of the tape rather than simplifying it as a single point charge. And this version of the value makes the model much more like real life. Then what if you had modeled each of your tapes as a single point charge like in the previous lab, compared to the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So what if that happened? Well, if that happened, then we would have the exact same result as in the last lab using it as a point charge. So yeah, as you see below, those are the two results we got for both the line charge and the point charge. And you can see that the line charge is much different and more accurate. And that is all I have. Thank you guys.